Welcome to Periodic Table Basics, an EOG review. Atoms have three subatomic particles. They have the protons, the neutrons, and the electrons. Protons are designated with a P positive because they are positively charged. And they have a mass of exactly 1 AMU, or atomic mass unit. Protons, like neutrons, are located in the nucleus. That's because the center of the atom is going to be where most of the mass of your atom is located. Neutrons are also in the nucleus. They have a mass of about 1 AMU as well, but they are neutrally charged. Electrons are those things swirling about the outside of your atom. They are negatively charged, and they are so small that even on the atomic scale, their mass is almost negligible. Of course, they have mass, because if they didn't have mass, they would not be considered matter. They reside in the orbitals, or shells, around the nucleus of the atom. Your electrons are going to be what interacts in a chemical reaction, because they're on the outside. But if you start messing with those things on the inside, that's when you've got a nuclear explosion or a nuclear reaction, because it's happening in the nucleus. So elements are arranged on the periodic table behind me by increasing atomic number. That's these numbers up here usually in the top corner on mine in my room, but it can be in the center, it could be on the bottom, but it's those ones without that decimal point. The atomic number is the number of protons. The protons are what identifies your elements. So this is not mass. This is where they're going to try to trick you on the EOG. So they'll say, is it by increasing atomic mass? Because it looks like it. 65, 69, 72, 74, 78. But then you have some non-examples where the mass doesn't increase. For instance, you go from 285 to 284, back up to 289, down to 288. So those are your proof that it's not increasing by mass. It only increases by atomic number, because this is the identifying feature for every element. There's no two elements that have the same atomic number or the number of protons. On your periodic table, you'll notice that you have elements arranged in rows as well as columns. Your rows are called periods, hence the periodic table. You start here with number 1 and you go across by 2. These are your periods. Columns are called groups. Elements are grouped by having similar chemical and physical properties, which affect their reactivity. We'll get into how they're arranged really shortly. So, for the major groups of your elements are your metals, your nonmetals, and your metalloids. Your metals are going to be those things that are solid at standard temperature and pressure, except for mercury, that Hg, that's our liquid. They're shiny. They're good conductors of electricity and heat. They're ductile, which means they can be stretched into long, thin wires. And they're malleable, meaning you can hammer them into thin sheets. And they usually have a really high density. These are ones that want to lose those electrons. And they corrode easily, like iron rusts and silver tarnishes. These are going to be from about here this way. These are all of your metals. This is the vast majority of elements on your periodic table are classified as metals. Non-metals, some are liquid, some are gas. They're brittle, meaning they break really easily, like you think about grandma's brittle bones. They're dull in color. They're poor conductors of heat and electricity. These are the types of questions that you'll be asked on the EOG. Which of the following elements is most likely to conduct electricity? So you're going to be looking for something over here for a metal that doesn't conduct electricity or heat. It's going to be over here. These are your non-metals. And you'll notice that I kind of went along a diagonal line. There's a stair-step line that isn't here on this periodic table, and it won't be drawn for you on the periodic table that you're given for the EOG, so you'll have to draw it yourself. If you simply remember, though, that it starts here between boron and aluminum, you can just make stair steps all the way down. Anything touching that stair step line is a metalloid. These are like your Goldilocks. They're not quite metals, they're not quite non-metals. They're malleables, but they're semiconductors. That's the part that you really want to remember. They're semiconductors, so therefore they're used in a lot of electronic devices when you want to be able to turn it off and turn it on. Anything that's going to be asking about computers or phones or microchips are going to be these guys right here, your metalloids. As you can see right here, on the periodic table, I've highlighted and drawn in a circle. All those dark green elements are going to be your metalloids. And follow that line straight down. So of course we're not going to color in our periodic table today, but you did do this in class. You can see all the different groups on the periodic table. Each group has different reactivity and physical and chemical properties. That's why they're arranged that way. That has to do with those valence electrons, those electrons on the outside, and how they're going to interact with other elements. So let's walk you through a couple of the major groups. The grouping. Group 1, you're going to start over here. You can even see they're labeled Group 1. These are your alkali earth metals. These, except for hydrogen, hydrogen doesn't count. It's gas, it's not a metal. There's always exceptions, which makes it a lot more difficult, which is frustrating, I know. But these are going to be very highly reactive. Recall those videos about the sodium exploding in the water, right? Because they've got that one extra electron and they want to get rid of it so desperately. You can see here a picture of sodium reacting with water. So they're softer than most other metals, and all of these are going to have that explosive with water characteristic. And the thing is about groups, the further down you go, the more reactive they are. So this one is going to want to get rid of that electron even worse than sodium. It's going to be more explosive than sodium. Those comparisons are types of questions you'll be asked, is which one is going to be more reactive. Your extremes right here are going to be the most reactive metals. And I don't necessarily think of sodium as a metal, but it's a soft metal. It is, in fact, a metal. Then our alkali earth metals are group 2. They're still pretty reactive, but they're less reactive than these guys because they've got 2 electrons. And getting rid of 2 electrons is a little bit more difficult than getting rid of just 1 electron. So, but they're still very reactive. Then in the middle here, this big middle chunk, are your transition metals. These are semi-reactive, but the only ones that have a magnetic field are iron, cobalt, and nickel, which are right here. So these ones have a magnetic field. Now moving away from our metals and into our non-metals, we've got our halogens. These, like our alkali metals, are very reactive because they are missing just 1 electron in their outer shell. They want that stability. These guys, that's why you have chlorine wants to react so much with sodium, because sodium has 1 extra electron to give, and chlorine just needs 1 electron to be completed. So halogen means salt producing. And again, these are going to be more reactive than this. Highly, highly reactive. Your 2 most reactive groups on the periodic table are your halogens and your alkali metals. And then last, but certainly not least, are the noble gases. Remember, we call them nobility, the noble gases, because we don't want to mess with the riffraff. They do not need anything from anyone at any time. They are stable as is. That outer valence shell is completely full, which means they're inert or they don't react. These are, when someone says they've got neon lights, they're actually different colors are by different gases. Neon's one of them, but other ones can be other colors as well. So the big key here is these guys don't need anything from anyone. They're always a gas, and hence noble gases, and they do not react. The rare earth elements are down here, and the big thing you want to know about them is they're important for technology and communication. For instance, your iPhone uses 8 rare earth elements, but they're not rare. They're just hard to come by. In fact, China produces 95%, so I pay them the big bucks. So again, you want to keep in mind, you've got the alkali metals, highly reactive. Over here, they have one extra electron. Then you've got the alkali earth metals, which have 2 extra electrons, still very reactive. In the middle here, you've got your transition metals. Then your metalloids. You've got your halogens, which are highly reactive, and your noble gases, which don't want anything to do with anybody at any time. So of course you're not going to build an atom right now with your Play-Doh, but I did just want to remind you of what goes where. That center green dot, that's where your nucleus is. That's where your neutrons and your protons are going to go. Then those orbitals are where your electrons go. Each orbital has a maximum number of electrons that they can hold. These are called your valence electrons. The electrons in the outermost shell are your valence electrons. How do you find out how many valence electrons you have? Well, you simply count. The periodic table will give you all of the answers you need. It's like having a dictionary, but you have to know how to use it. So, hydrogen has 1 proton, no neutrons, 1 electron, and it's in the first group, 1 orbital. But that first orbital is full. You know it's full because this is your noble gas, and they are inert by definition. Has 2 valence electrons. 1, 2. That's as many electrons as possible in that first orbital. And then your period, remember again, those are your rows, tell you how many orbitals, or those rings outside, your element actually has. So lithium will have 1 orbital that's full, a second orbital with just 1 valence electron, in it. So remember, using the periodic table, if you know how to use it, you should be able to find the atomic number, the atomic mass, the number of protons, number of neutrons, number of electrons, number of valence electrons, and number of orbitals for any element on the periodic table. You should also be able to define the reactivity of the element, being able to compare what's going to be more reactive or less reactive. If it conducts electricity, or the density, the luster. Again, that's just being able to identify it as a metal, a nonmetal, or metalloid. The element name and the element symbol. All of that information is available to you on your periodic table, and you will have a periodic table in the EOG. It's just, do you know how to use it? Thank you, and again, this is a review of periodic table basics for the EOG review for 8th grade science.